Look at anything built with care. A bridge, a circuit board, the map on your phone, a whole game world. Underneath, it's all made from a handful of simple parts, just a few. Learn those parts, and geometry stops being a wall of rules and turns into a set of pieces you can see and build with. So let's meet them, starting with the simplest thing there is. This is a point. That's the whole thing, a single dot that marks one exact position and nothing more. It has no width and no height, and it doesn't stretch in any direction. Think of it as the answer to one question. Where? Right here. We usually give a point a capital letter so we can talk about it, and this one is A. Everything else we build today starts from points like this one. Now put down a second point, B. Join A to B with a straight path, and you get a line segment. That word, segment, is the important part. It's a piece. It has a definite start and a definite stop, the two endpoints, so it also has a length you could measure with a ruler. A segment is the straight connection between 2 points, and it goes exactly that far, no further. Here's where it gets interesting. Keep the starting point, A, but instead of stopping at B, let the path carry on past B and never stop. That's a ray. A ray has one endpoint where it begins, and then it travels out in a single direction forever. A good picture for it is a beam of light. It starts at the torch, and it simply keeps going. One end anchored, the other end open. And if one open end is good, why not two? Take that endpoint away as well, and let it run without end in both directions. Now nothing pins it down on either side, and that's a straight line. So look at what we've built, just by choosing how many ends to leave open. A point is a position. A segment is closed at both ends. A ray is closed at one. A line is closed at neither, endless both ways. The same straight idea, with 4 different amounts of forever. Bring in a second straight line, and there are really only 2 things that can happen. Either the 2 lines cross, and when they cross, they meet at exactly 1 point, never more than 1. We say they intersect, or they run side by side, always the same distance apart, and however far you follow them, they never meet. Those are parallel lines. Picture a long, straight railway, the 2 rails running on together and never touching. Go back to the moment 2 rays share the same endpoint. The corner they make, the opening between them, is an angle, and that shared point is called the vertex. The wider the opening, the bigger the angle, and there are 3 you should know on sight. When the 2 rays make a perfectly square corner, like the corner of this book, or where a wall meets the floor, that's a right angle. Open it less than that, tighter and sharper, and it's an acute angle. Open it wider than a square corner, and it's an obtuse angle. Sharp, square, wide. Your turn. Here are 3 angles. Don't measure them. Just look and compare each one to a square corner in your head. Which one is the right angle? Which is acute, the sharp one? And which is obtuse, the wide one? Pause here and decide before I tell you. Here they are. The square corner is the right angle, the sharp one is acute, and the wide one is obtuse. If you saw that by eye alone, you've got it. So here's the whole family in one line. A point marks a position. Join 2 points and you get a segment. Free one end and it becomes a ray. Free both and it becomes a line. Let 2 lines meet at a point and they intersect. Let them run on forever without meeting and they're parallel. And 2 rays from one vertex open up an angle, right? Acute or obtuse. That's the entire alphabet of shapes, and every figure you'll ever draw is spelled out of these. Here's something to try. Look around the room you're in right now and find one of each. A straight edge that's really a segment, 2 parallel lines, and a good square right angle. They're everywhere once you know their names. That's all for this video.